Let's find the limit as n approaches infinity of square root of n squared plus 1 over n plus 1 raised to the nth power. As n approaches infinity, we have 1 raised to the infinity power, so the limit is indeterminate. And in order to solve this, I'm going to rewrite this as e to the natural log of the square root of n squared plus 1 over n plus 1 raised to the nth power, and we're going to let n approach infinity. So now we can take advantage of the log property to bring down the exponent. And when I bring the exponent out in front, I'm going to say that n is the same thing as 1 over n. So we're going to take the reciprocal of the reciprocal, like this. At this point, we know that as n approaches infinity, the inside of the natural log goes to 1. So you have natural log of 1 is 0, and then 1 over n also goes to 0. So we can use L'Hopital's rule. And we can also bring the limit as part of the exponent. So bringing it as part of the exponent, you get 0 over 0, you use L'Hopital's rule, and that says to take the derivative of the numerator, which is going to be n minus 1 over n plus 1 times n squared plus 1. And the derivative of 1 over n is just negative 1 over n squared, which, since I'm dividing by negative 1 over n squared, that's the same thing as multiplying by negative 1 over n, or by negative n squared. So you have negative n squared times n minus 1 over n plus 1 n squared plus 1, and multiplying it out, get negative n cubed plus n squared over n cubed plus n squared plus n plus 1. I'm going to divide everything by n cubed. So that's negative 1 plus 1 over n over 1 plus 1 over n plus 1 over n squared plus 1 over n cubed. As n approaches infinity, these will go to 0, and we're just left with e to the negative 1 power, or 1 over e, and that's going to be our limit.